Hi guys, in today's class, I'm going to explain about the classification of polygons. Sometimes I may use coordinate plane, sometimes without using that. So the learning target for the day is uh, I mean to say that you will be, you will be able to compute lengths of sides of polygons, hence classify the polygons based on their lengths. So in my previous class, I already explained the distance formula, okay, which is x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Again, when 2 points are given, which point is to be taken as x1, y1, which point is to be taken as x2, y2 means actually it doesn't matter. It doesn't matter. For example, if you want to take this point as x1, y1, it's fine. Or else, if you want to take this point as x1, y1, still that's fine. And another point is, by any chance, if you write the order here like x1 minus x2 whole square instead of x2 minus x1 whole square plus y1 minus y2 whole square instead of y2 minus y1 whole square, still that is acceptable order. Okay, so let's quickly jump to the questions. Choose the most specific name for quadrilateral ABCD given. The points are also given. I think, yeah, 4 points. I think these are duplicated. My bad. So just give me a second. I'll eliminate these doubles. Well, the doubles are removed now. Actually, this one seems to be a square because all the four sides seems to be equal. So let's confirm. So first one is let me start working and let me find what is the length of I'm sorry, what is the length of AB, then what is the length of BC, what is the length of DC, and what is the length of AD. So all these four sides you have to find what is the length of that. So let me find the length of AB. So please be mention which side length you are taking. Okay, so the distance formula, you know that it is x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Okay, now if I'm taking AB, so let me take point A, which is x1 y1 and the second one is x2 y2. So now let me plug in these values. X2 is negative 3 subtract x1 is negative 2. So in my previous class I mentioned that if there are the double negative signs, if they are occurring side by side, use extra parenthesis. Then y2 is negative 1 subtract y1 is 4. So here I am using only single parenthesis because no double negatives. Okay, so square root of this one. So negative 3 again. Don't be lazy. I know that it's you can compute in mind, but still I advise you to write in detail. So negative of negative, that gives me positive 2 square plus negative 1 negative 4 whole square. You know, if you want to, you can simplify the second part. So let me simplify this part. Negative 3 positive 2 negative 3. I see that these two are having different signs, so I have to subtract 3 minus 2, that I'll get 1. Then it's going to be negative 1 square. In my previous class I mentioned please use parenthesis for negative 1. Otherwise, what happens is -1 square, -1 square. These two gives you two different answers because this square belongs to only to this one. Then you should get -1, and this one you should get +1. Actually, I explained this one in my previous class, so just let me not go deep into that. And next, -1, -4. I see that these two are having the same signs, that is negative sign. So I have to combine them to get -5 square. Therefore, here I'll get +1, and 5 times 5, I get 25. Then this one is 1 plus 25 equals to square root of 26. Well, again, I have to, oops, I'm sorry, I have to find, my bad. So let me, it's not, okay, right. So let me write the formula once again, which is BC. This time I'm trying to find the length of BC. So BC, distance formula, x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Okay, so what is I'm taking B and C, so this time you can take it as x3 y3, no problem. So -2 subtract -3 whole square plus this one is y3, which is -2 subtract y1 is -1 whole square. Okay, so I'll do one thing. At this point, I want you to find BC, then length of CD, and next length of AD, all these four on your own. You may make use of calculator, and it'll give you about few minutes of time to complete that. Then I'll show what are my answers. Then you can check your answers with your working, and if there are any mistakes, then you can make necessary changes. Okay. Well, so here you see that all the four sides are there. We got a square root of 26. So this is square root of 26, and the length of BC is also square root of 26, and this is also square root of 26, which is CD, and AD, that is square root of 26. So here I see that all these four lengths, I got square root 26, square root 26, square root 26, and square root 26. So if you are taking a test, if you are given a question, say that let's say that options are the rectangle, next trapezoid, next is maybe parallelogram, and option D is let's say that it is a rhombus. It's a rhombus. Now you see that all the four sides are equal. So obviously we go with all the four sides are equal, means that is a rhombus, right? Suppose instead of rhombus, let's assume that instead of rhombus, you are given the option D as a square. Let's assume that you are given a square. Now, which is the appropriate one means then we take option D, which is a square, right? Then you should get a doubt. How about if you are given both the options rhombus or square, in case if you are given both the options, then the problem arises, because we know that it is not a rectangle and it is not a trapezoid, it's not a parallelogram, and in a square I know that all the four sides are equal, and in a rhombus all the four sides are equal. In such case, then you have to go an extra mile and you have to compute what is the length of the diagonal AC and what is the length of diagonal BD. Suppose if the diagonals, the length of diagonals are equal, then it is going to be the square. In case if the diagonals are unequal, then it's going to be rhombus. Okay. Questions on this? All right. So let's go to next one. Now polygon WXYZ contains the following points. I think again here also the points are duplicated, so just let me take them away. Well, what is the best name for the quadrilateral WXYZ? So once again, we find the length of. So let me try a freehand sketch. I know that the diagram is not given, so just let me plot the points. This is a freehand sketch. It need not resemble with the main one. I mean, it may not represent the actual figure. So W, X, Y, Z. Okay, the points. This is O3. X is negative 2 comma 0. Y is 0 comma negative 2, and Z is 2 comma 1. Okay, so what you are supposed to do is the strategy is find the length of Wx. Okay, use the distance formula, then find the length of xy, find the length of yz, and find the length of zw or wz. Suppose if all the four sides are equal, then you can state that it is a rhombus. If opposite sides are equal, then you can say that it is a parallelogram. In case if in the given options, suppose a square or a rectangle are also given, then let's say that rectangle are also given, then you have to think of those properties. So the basic difference between a square and let me take a little thicker. Okay, a square and a parallelogram is actually both are having most of the properties are the same, and where the difference is, just give me a second. Here I'm going to explain. Okay, so this is a parallelogram, right? And you see that the main difference between these two is the corners are not at 90 degrees. Here you can compute their slopes and you can check whether they are whether the corners are at 90 or not. That is one option. And second option is find the length of diagonals. Find the length of diagonals. And you see the difference between the length of diagonals in both the pictures. You see that in a rectangle, the diagonals length, the diagonals are equal, which means length of AC equal to length of BD, right? And when it comes to a parallelogram, the similarity is opposite sides are equal, just like the rectangle. But when it comes to diagonals, look at the diagonal PR and QS. So length of PR and length of QS, when you look at them, then you see that the diagonals are unequal. That makes a difference, right? In the same way, if you are taking a square and a rhombus, what is the basic difference means, which is almost same as the above one. Like if I'm taking a rhombus in which all the four sides are equal, and if I'm taking a square, the main difference is, you see that rhombus is slightly tilted. You know that, okay? This is the rhombus and it is slightly tilted, and this one is the square. Okay, so another difference is, if you take the diagonals in a square, the length of diagonals, yes, they're equal, and in a rhombus, you see that the diagonals are unequal. One is longer and one is shorter. So, in case if you are given both the options, whether it is a square or a rhombus, means in such case you have to find the length of the diagonals, which is length of AC and length of BD, to check whether the diagonals are equal or not. If the diagonals are equal, you can say that it is a square. If the diagonals are unequal, then you can state that it's a rhombus. Anyhow, for this question, I'm not computing because you have to use the distance formula to figure out what are the values. Okay, once when you find it, if it is a test and based on the options, in case if you have given a question that contains whether it is a square or a rhombus and you got all the four sides are equal, then in such case you have to focus on the length of diagonals, then find the length of both the diagonals. If they're equal, yes, it is a square, and if the diagonals are unequal, then it's a rhombus, right? Now, questions on this? All right. Well, in this question, just assume that there is a circle. Okay, there is a circle, and there is a point. This is the center. Suppose a circle C has the center at the horizon. Horizon means, if there is a graph sheet, the point where x-axis and y-axis, these two intersects. Oops, I'm sorry. Let me take a straight edge. So this is the y-axis and this is the x-axis where these two are meeting. That point is known as the horizon. So let's go to this point and say that this point is 0, 0. How do you know means? Please remember the point of intersection of these two is 0, 0. You know that. And contains the point 5, negative 2. So the value of x is 5 and the value of y is negative 2. So let's say that somewhere here, just I'm taking randomly a point which is 5 comma negative 2. And next, this is really interesting, that does the point negative 2, 5 lie on the circle? Does it lie on the circle or not? Okay, let me assume that this point negative 2 comma root 5, that is also lying. Just I'm assuming, let's assume that negative 2 root 5 is lying on this. Let's assume that way. Okay, in such case, I call this one, let me label this one as say that this is center C, and this is point A, and this is point B. So I know that 5 comma negative 2 is on the circle. Therefore, I call this one as radius, right? Suppose if point B, which is negative 2 comma 5, is also lying. If it is also lying, I don't know whether it is lying on the circle or is it outside, or is it inside the circle? Really, I don't know. Okay, so let's do one thing. First, to find the radius of the circle, which is AC. Okay, so let me find the length of AC. So length of AC, let me use the distance formula, which is x2 subtract x1 whole square plus y2 subtract y1 whole square. This is under the square root. Okay, so x2, let me take this as x1 y1, this is x2 y2. So x2 is, you can see that it is 5 subtract 0. So it is 5 subtract 0 square plus y2 is negative 2 subtract 0. So negative 2 subtract 0 square. 5 minus 0, that gives me 5 square. And negative 2 minus 0, negative 2 square. 5 square is 5 times 5, 25. Negative 2 square is, okay, so it is square root of 29. Okay, now stop here. Then coming to the length of CB, okay, let me make use of the same formula. So copy paste this formula. Okay, so let me use the same formula on the other side. Okay, let me move this circle a little right side so that I'll have some place for working. Okay, right. Now let's quickly plug in these values and check. This time I'm taking, this is x2 y2 because already marked as x1 y1 here. So negative 2 subtract 0 square plus square root 5 subtract 0 whole square under the square root. So negative 2 subtracts 0, that gives me negative 2 square. 5, I mean square root of 5 subtract 0, square root 5 square. Negative 2 square, negative 2 times negative 2, that gives me 4. Square root 5 square. Here the square root 5 square means I have to multiply this one. Square root 5 times square root 5, that gives me 5 times 5, 25. So again square root of 25 is 5. So this value I'm taking here, so that gives me 4 plus 5 equals to square root 9. I know that square root 9 equals to root 3, but I don't want to compute that because I want to compare with square root of 29. I see that square root of 29 is larger than square root of 9. Square root of 9 is the smaller, right? This is how I compare. I know square root of 29 is larger and square root of 9 is smaller. Okay, therefore let me join these points, then I get that 29 is longer than square root of 9. So I see that AC, this one is longer and this one is shorter, right? Therefore, if this is shorter, means it must be smaller than radius, means this point B is not on the circle. It is not on the circle. So the question is, does it lie on the circle? Means the answer is no, it does not lie on the circle. Okay, because it is shorter than It is shorter than the radius. Okay. Any questions on this? Okay. Let's go to the next question. Which of the following procedures is sufficient to prove a given quadrilateral is a square? Quadrilateral is a square. In fact, this one I explained in my previous classes. Suppose if you take a parallelogram, let me make a parallelogram, then, and you are asked to prove that this one has a square. So you have to think of what are the unique qualities of a square as compared to a parallelogram. I know that in a parallelogram opposite sides are equal, right? And in a square also opposite sides are equal. But the unique feature is all the four sides are equal, right? So let's look for that point. The first one is prove that slopes of adjacent sides are perpendicular. Perpendicular means he's talking about the four corners are at 90. Not bad. In case if all the four corners are 90, then can I call this one as a square? Means the answer is no, because it could be a rectangle also. Because in a rectangle all the four sides are equal, right? Therefore, I would say that no. Prove that the adjacent sides are congruent. Adjacent sides are congruent means, let's say that if I compute by using distance formula, say that this is 7 units, just I'm taking some number randomly. This is 7, this is 7, and this one is 7. So can I say that it is a square? A square. If all the four sides are equal, can I call it as a square? No, because in a rhombus also all the four sides are equal. So not this one too. Prove that the diagonals are perpendicular. Actually, I'm not having enough space, but I know that. Otherwise, let me draw that. No problem. Okay. Okay. Let me take. Probably this would be fine. Okay. Just assume that this is a rhombus. So what is the difference between a rhombus and a square? Means, in a rhombus, the diagonals bisect each other at 90 degrees, and also in a square, the diagonals bisect each other at 90 degrees. Okay, so that point is common in both square and rhombus. Therefore, this also cannot be. Prove that all the sides are congruent. All sides are congruent. Okay, so if it is all four sides are congruent, means it could be a square or it could be a rhombus, right? And also show that the diagonals are congruent. The diagonals are congruent. You see that all the four sides are equal means it could be a rhombus, it could be a square, right? But diagonals are congruent means it must be a square, because in a rhombus the diagonals are not congruent, right? Questions on this? All right, let's go to next one. Which method was used to prove quadrilateral ABCD is a parallelogram? Given, it's given. Okay, so here's points ABCD are given and slope AB blah 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 are given, and this time a quadrilateral is a parallelogram. So here the question is about a parallelogram. So let me think of parallelogram and let me draw a freehand sketch of a parallelogram. So let me draw a freehand sketch of a parallelogram. So this is the parallelogram. Okay, now, so let's see by properties. It was proved that both pairs of diagonals bisect one another. Earlier also I told you that all the properties of parallelogram are obeyed by square, rhombus, rectangle. 2. So it was proved that both pairs of sides are parallel. I think I need not look at it at all. Straight away I'll go with this one. Okay. Then how can you make use of these slopes to find that the sides are parallel? Do you remember earlier, maybe in the beginning of the year, you learned that if the slopes are equal, here I see that slope AB is given as 3. You see that slope AB is 3, and slope CD, which means these two are opposite. That means slope AB equals to, you see that slope AB equals to slope CD. Therefore, AB must be parallel to CD. Please do remember, if the slopes are equal, then the lines are parallel. Therefore, slope AB equal to slope CD. Okay, if the slopes are the same, then the lines are parallel. In the same way, if you take slope BC, which is 2/3, and slope AD, this is also 2/3. Therefore, I see that slope BC equals to slope AD. If the slopes are the same, then the lines are parallel. Therefore, here BC is parallel to AD. So this is parallel to this one, right? So as the opposite sides are parallel, then it must be a parallelogram. Questions on this? Okay, let's go to the next one. Name the triangle formed in the given diagram. Here, you are asked to identify what kind of triangle is this one. So you have to find the length of AB, and find the length of this one. You have to find the length of AB, AC, and BC. So length of AB, BC, and length of AC. Okay, I'm sure you know how to make use of the distance formula. So distance equals to y2, it is x2 subtract x1 whole square plus y2 subtract y1 whole square under the square root. Okay, so you know how to find the length of BC and AC. I'll give you about I'll give you a few minutes of time for you to work on this and compute, and you let's classify. Okay, I'll show you the answers. Then please keep the answers ready. Show all of you working. Everything you work it on a piece of paper, and at the end you can compare your answers. So what are the length of AB, BC, and AC? You got it? Then you can compare with my answer whether is it matching or not. Okay, so your time start now. So here is the solution. When you compute the length of AB, you should get square root of 13, and length of BC is square root of 37, and length of AC equals to square root of 10. In fact, I am not converting them into decimals, just you can leave them as they are. And you see that these three values are different. None of them are equal, so may call them as equilateral triangle or isosceles triangle or scalene triangle. You know that. You see that all the three sides are different, right? So AB is square root 13 and BC is square root of 37 and AC is square root of 10. So as all the three sides are unequal, as all the three sides are unequal, or you can say that different. Okay, if two sides are equal, we say that it is an isosceles triangle. If all the three sides are equal, it is equilateral. Therefore here all the three are different. Therefore this is going to be a scalene triangle. Okay, so any questions on this?